Hey guys, what's happening? So this will be the last bit of notes for the first semester. So we're going to be solving radical equations. They're totally awesome. They're totally radical. Let's do it. All right, here we go. All right, we'll start off with the easy examples. Part A, we have the square root of 10x plus 9, and that equals 7. All right, and this is what you do. These are the easy ones, trust me, okay? Remember, x is inside of a square root, so you need to get rid of that square root because you're solving for x, right? So what trick do you know that gets rid of the square root? Well, you square both sides. So I'm going to go ahead and recopy it again so you could see what the step was, okay? Equals 7. I'm going to go ahead and square both sides, all right? And now the square cancels the square root, so I'm left with 10x plus 9. And that's equal to 7 squared is 49. All right, now just solve it like a regular equation. So subtract 9 on both sides, and you get 10x equals 40, and of course x equals 4. Okay, and you could plug it in, right? 10 times 4, right? Plug in 4. 10 times 4 is 40 plus 9 is 49. Square root of 49 is 7. 7 equals 7, okay? And remember, you don't have to put like plus or minus or anything like that because we are squaring both sides. We're not square rooting, okay? So anyway, that's one of the easy ones. Let's try another easy one. How about this? The cubed root, ooh boy, this is fun, of x minus 2, okay, plus 1 equals negative 2. All right. So these guys right here, what you want to do, you want to isolate that cubed root, okay? So we're going to move that 1 to the other side, okay? So subtract 1 over. So now we're left with the cubed root of x minus 2, right? We're going to subtract 1 on both sides. So that equals negative 2 and negative 1 is negative 3, okay? All right. And remember this example, we squared both sides, okay? What do you think we're going to have to do here? That's right, we're going to cube both sides, okay? So I'm going to cube this, and I'll cube this entire thing. So the cube cancels out the cubed root, so I'm just left with x minus 2, and that's going to equal negative 3 times negative 3 is 9, times negative 3 is negative 27, okay? Now add the 2 over to the other side, and x equals negative 25, okay? And let's check it. Ready? Plug in the negative 25. Negative 25 minus 2 is negative 27. The cubed root of negative 27 is negative 3. And negative 3 plus 1, that's negative 2. We did it. Yay. Woohoo. All right. Let's do one that looks slightly different. Okay, try this guy. We have 9 times x to the 3/5. Oh my gosh. Okay, equals 72. All right. Well, keep in mind, to start this one off, we had the radical on its own on one side of the equation. This guy we didn't, so we moved that 1 over, so we got the radical on its own. That way we could cube both sides, okay? This time the radical isn't on its own. It's got a 9 attached to this x to the 3/5, so let's get rid of that 9. So we'll divide both sides by 9, okay? And we're left with x to the 3/5 equals 72 divided by 9. Hopefully that's 8, okay? All right, cool. So now the trick with this guy is, remember the power here is 3. What would you do to get rid of that? You would take the cubed root, right? The root here is 5. What would you do to get rid of that? You would raise it to the power of 5, right? So if you caught that, the trick is to raise this to the power of that reciprocal, to the power of the 5/3, okay? And we'll do the same thing here, raise it to the power of 5/3, okay? So now the 3/5 times the 5/3 cancels. We're just left with x equals, okay? And now, ready? Do the root first, okay? So the cubed root of 8 is 2, and then 2 to the 5th power is, I hope, 32. All right, so that's how those problems are going to work, okay? And we could do that here. Watch, ready? Ready, watch this. Plug in the 32. What's the 5th root of 32? That's 2, okay? And 2 raised to the 3rd power is 8. times 9 is 72. Done. Okay. All right, now let's get into some weird ones. Here we go. I'm just going to do one example of each. Okay. So here we go. We have to remember to check for extraneous solutions. Okay. And you'll know it when you see it. Okay, watch this example. We have x minus 10 is equal to the square root of 32x. All right. Now, if you look at all these examples above, this guy right here, there's only an x inside of a radical, okay? You don't see an x anywhere else. Same with this. The only x you see is inside of a radical, and same with this. If you look at this problem, the difference is you have an x inside of a radical, but you also have another x outside that radical. So that's why this one is a little bit different, okay? All right, so here's how we're going to handle it, okay? You're going to go ahead and keep that, isolate that, okay? If there was a 10 over here, you would want to move it over, okay? And here, I'm going to rewrite it. X minus 10 equals the square root of 32x, okay? Again, you always want to, if you can, every single time, make sure that the radical is on one side isolated, okay? All right, and watch what I'm going to do. I'm going to square both sides, okay? Because this is a square root, I want to get that x outside of it, so that'll cancel the square root. So now x minus 10 squared, okay, that's x minus 10 times x minus 10. I'm going to do it quickly in my head, okay? So this is going to be x squared, and then negative 10 times x is negative 10x, and then another one, so we're going to get negative 20x, okay? And if you miss that, just write it out, x minus 10 times x minus 10 and use FOIL, okay? And then negative 10 times negative 10 is positive 100, okay? Equals, and then this cancels the square root, so we're left with 32x. Okay, now combine like terms. Move that over, so we get x squared. Subtract 32x, combined with negative 20x is negative 52x, plus 100 equals 0. All right, and here we go. This looks factorable. I mean, I'm hoping it is, okay? That would be a bummer if it wasn't. Doing all this work and then having to use quadratic formula. But anyway, you can if you want. Here we go, x and x, okay? Factors of 100, I see 50 and 2. So we'll go 50 and 2, okay? And let's go insides, 50x, and outsides is 2x. I need both of them negative to give me negative 52. So negative and negative. Multiply them, I get positive 100, I'm good. So here, x equals 50, and here x equals 2. Now it looks like I'm done, so here's what we're gonna have to do. We need to plug these guys in to the original, okay? That's why I wrote it twice, so you wouldn't mess up the original, because you want to plug this in. Ready? 50 minus 10, what is that? Okay, that's 40, okay, so 40 equals, plug in the 50. 32 times 50, I don't know, what is that? Probably 1600. I'm just guessing. I'm just guessing. Let's see. Clear that guy. Oh, there it was. I had it. I did have it. It was 1600. I must have done that earlier. Okay. So the square root of 1600, and that's 40. And that's true. That works. Okay. The square root of 1600 is 40. Now let's plug in the 2. 2 minus 10. Okay. What is that? Negative 8. Let's see what that equals. 32. Let's see, times 2, so the square root, okay, 32 times 2, the square root of that is 64, and so negative 8 equals, the square root of that is 8. Those do not work, okay? So this guy is not a solution. This guy is your solution right here, okay? You always have to check for extraneous solutions. All right, we're going to do one more example. This guy's a monster. This one's insane. All right, let's do part C. Okay, here's my example, and we're going to check again for extraneous solutions, okay? So I'll put a little reminder here, check solutions. Yay. Okay, here it is. Example. We have the square root of 2x plus 3 plus 2 equals the square root of 6x plus 7. All right, and that's all under the radical there. Okay, and so is this. All right, so notice what's weird about this one. You have a x under the radical. You also have another x under the radical, okay? So this guy's gonna be crazy. So there's really no way you can isolate the radical, okay? Remember how on these problems I said you really gotta get the radical by itself, okay? Doesn't work here, you can't do it. Because if I move the 2 over, that one will be by itself, but that one won't be, okay? So we're just gonna work with it how it is. So square both sides, okay? So square that. Square that. Okay, now I'm going to write this one out because I think most of you guys are going to be really confused here. So I'm going to write this out. The square root of 2x plus 3 plus 2, right, times the square root of 2x plus 3 plus 2, okay, equals, well, this guy, the square cancels that, so we're just left with 6x plus 7. I hope you're okay with that, right? The square cancels the square root, so 6x plus 7. All right, here we go. This is fun. The square root of 2x plus 3 times the square root of 2x plus 3. What is that? Well, it's the square root of 2x plus 3 squared. The square cancels the square root, so we're just left with 2x plus 3. Did you catch that? That's the good stuff, all right? Now, the square root of 2x plus 3 times 2, that's going to be 2 of those guys, plus another 2 of them, right? So now we have plus 4 of the square root of 2x plus 3, right? So we have these 2 plus these 2 is 4 of them altogether, okay? And then finally, FOIL says multiply those 2, we get plus 4. So I have plus 4. Okay, and that equals 6x plus 7. All right. All right, here we go. Now let's get this guy by itself. So move this over, and move this over. So I'm going to move all that stuff over. I'm left with 4 times the square root of 2x plus 3, okay, equals, all right, subtract the 2x to the other side. So 6x take away 2x is 4x, okay. Subtract the 3 and subtract the 4. So altogether I'm subtracting 7, right? So if I subtract 7 to the other side, it cancels out that 7. So I'm just left with 4x. That was nice. Okay, that's going to make my life a little bit easier. All right, finally, here we go. I have a square root. I want to get rid of that 4, so move that 4 over. So I have the square root of 2x plus 3 equals, right, I divide 4 on both sides, divide by 4, so that equals x. This is great. Now I square both sides. Square it, square it. The square cancels the square root. I'm left with 2x plus 3 equals x squared. Okay. Now it's a quadratic. Move those guys over. So I'm just going to move these guys over and start with x squared. So x squared minus 2x minus 3 equals 0. Okay. I think that's factorable. All right. X and x. Factors of 3 are 3 and 1. The insides is 3x. The outsides is 1x. I'm trying to get negative 2x. So negative 3 plus 1 gives me negative 2. So bring down the negative, bring down the positive. Here, x equals 3, and x equals negative 1. All right, let's plug it in. Oh, look what I forgot to do. I forgot to leave it alone. Bummer. So here, I'm just going to rewrite it so I don't get confused. The square root of 2x plus 3 plus 2 equals the square root of 6x plus 7. All right, so I'm going to plug in 3, okay? So 2 times 3 is 6, plus 3 is 9. The square root of 9 is 3, plus 2 is 5. Okay, let's see if that equals the same thing. I'm plugging in 3. 6 times 3 is 18, plus 7 is 25. The square root of 25 is 5. So that one checks. Okay, 3 is a good solution. All right, now let's plug in negative 1. Okay, so 2 times negative 1 is negative 2. Negative 2 plus 3 is 1. The square root of 1 is 1 plus 2 is 3. Okay, and plug in negative 1 right here. 6 times negative 1 is negative 6. Negative 6 plus 7 is 1. Square root of 1 is 1. And 3 does not equal 1, so this is not a good solution. Okay, and that's it. And I'm out of time. Talk to you guys soon. Peace.